Hi, hello, very good evening, dear students. Last class we discussed the term effective atomic number of coordination compounds. So we are going to start today Werner's theory. So what is Werner's theory and why we are using the Werner's theory in the coordination compounds? We will discuss here. So Werner's theory is the first proposed theory in the coordination compounds. The coordination compound topic, Werner's theory is the first proposed theory, right? So it is proposed by the Werner scientist. Now, it is proposed by the Werner scientists to explain the properties and structures of various metals, metal amines of cobalt, chromium, platinum, and etc. So, generally, Werner scientist is proposed the theory, the Werner's theory. Why he proposed nothing but to explain the properties and structures of metal amines of cobalt, platinum, and chromium. So, generally we observe the coordination compounds. In the coordination compounds, central metal atom is present. Around the central metal atom, ligands is present. Okay. So, the central metal atom, if it is cobalt, chromium, or platinum, or etc., if the ligand is amines, okay. So, central metal atom, cobalt, chromium, platinum, and etc., and the ligand, if it is amine, such type of coordination complexes, properties, and structure, it is explained by the Werner's theory. Right. So, according to Werner scientist, okay, according to Werner scientist here, so in the Werner's theory, main postulates. So, what is the main characters or what is the main postulates here? Right. So, according to this theory, every element exhibit two types of valences. According to Werner theory, every element is exhibit the two types of valences. One is primary valency and one more is secondary valency. One is primary valency and one more is what? Secondary valency. So, one we call as a primary valency and another valency we call as a secondary valency. According to valency theory, every element exhibit two valencies. One is primary valency and one more is what? Secondary valency. So, generally, primary valency, it is correspond to the charge of the central metal atom. Okay, primary valency corresponding to the charge on the central metal atom. So, I am writing here primary valency. It is correspond to the charge on the central metal atom. Charge on the central metallic atom. So, secondary valency correspond to the coordination number on the central metal atom. Secondary valency correspond to the coordination number of the central metal atom. Simply we can say that primary valency satisfied primary valency represent the charge on the central metal atom. Secondary valency represent the coordination number of the central metal atom. And primary valency satisfied by the negative ions. Primary valency satisfied by the negative ion and the secondary valency satisfied by the neutral molecule at the same time negative ion also. Neutral molecule at the same time negative ions also. So, primary valency is satisfied by the negative ion and the secondary valency is satisfied by the neutral molecule at the same time negative ion. Next of all, primary valency generally is showing the symbol with the dotted line. Secondary valency is showing the symbol with the thick line. Secondary valency is showing the symbol with what? Thick line. Primary valency we call as a ionizable valency. Primary valency we call as a ionizable valency. And secondary valency we can say that non-ionizable valency. Secondary valency we can say that is what? Non-ionizable valency. So these are the characters of the primary valency and secondary valency according to the Werner's theory. So once again, primary valency, it is represent the charge on the central metal atom. In the coordination compounds, central metal atom, on the central metal atom charge is present. The charge is represented by the primary valency. And every central metal atom in the coordination every central metal atom in the coordination complex is the central metal atom in the coordination number, that is represented by the secondary valency. And the primary valency is satisfied by the negative ions. At the same time, the secondary valency is satisfied by the neutral molecule at the same time negative ion. And the primary valency, we are showing the symbol with the dotted line. Secondary valency is showing the symbol with thick line. And the primary valency we can say as a ionizable valency. Secondary valency is non-ionizable valency. So generally, these are the characters of the Werner's theory, or these are the postulates of the Werner's theory. So now how it is possible and how we can apply in the coordination complexes we are going to discuss. So now here, if you know the oxidation state or charge of the central metal atom, so generally we can say that or we can predict the coordination number of that atom. So generally, if you know the oxidation state of the central metal atom, we can predict or we can guess the coordination number of the particular central metal atom. So now, if the oxidation state of the central metal atom, if it is 2, oxidation state of the central metal atom, if it is 2, we can guess the, or we can predict the coordination number is 4. Next, if the oxidation state of the central metal atom, if it is 3 or 4, oxidation state of the central metal atom, if it is 3 or 4, we can say that the coordination number of the particular central metal atom is 6. Coordination number of the central metal atom is what? 6. So, depend on the oxidation state, we can say that the coordination number. And depend on the coordination number of the central metal atom, we can say that geometry of the molecule. So, for example, coordination number of the central metal atom, if it is 4, we can say the geometry is a tetrahedral or spherical geometry, we can say that. And if the coordination number of the central metal atom, if it is 6, we can say that complex geometry is octahedral geometry. So, now what we are saying here, depend on the oxidation state, we can guess the coordination number. Depend on the coordination number of the central metal atom, we can say the geometry of the complex. So, generally, we can say this one based on the Werner's theory. So, now we will see that some examples. Based on the example, we can understand how the Werner's theory is useful for the primary valency and the secondary valency, how it will be explained. So, now here, for example, I am taking the molecule. Example I am taking, that is CONH3, 6 and Cl, CONH3, 6 and Cl, right? So now here the species which is present in the square bracket, we are saying as a coordination sphere. Okay, the species which is present in the square bracket, generally that we call as the coordination sphere. After the square bracket, what ions or what species is present, generally that we call as a counter ions. Now, here what is present? Inside the square bracket, one ligand is present. What is that? Ammonia. How many ligands is present? 6 ligands is present. And this ligand is a neutral ligand. This ligand is what? Neutral ligand. And after the square bracket here, some negative ion is present. This is what? Negative ion is present. So, how many negative ions is present? 3 negative ions is present. So, these 3 negative ions, okay, it is present after the coordination sphere. So, after the coordination sphere, if any ion is present, generally that we call as a counter ion. Generally, what you call that is a counter ion. So, here counter ions is 3 is present and the ligands is 6 and one central metal atom is present. Now, in this complex, we have to identify the primary valency and secondary valency. In this complex, what you have to identify? You have to identify the primary valency and secondary valency. So, just now we discussed that primary valency, it is corresponding to the primary valencies represent the charge on the central metal atom. Primary valency represent the charge on the central metal atom. So, what is the charge on the central metal atom? How can you identify the charge on the central metal atom? See here, central metal atom, if you don't know the central metal atom charge, the charge you can take as a X plus here ligand. Ligand is what type of ligand? Neutral ligand. Neutral ligand, nothing but the charge is 0. Right. So next, after the coordination sphere, which type of ion is present? Negative ion. So negative ion, nothing but which negative ion? That is chloride. The charge is -1. So how many chloride ions is present here? 3. That means it is a 3. So now it is equal to 0. That means x minus 3 is equal to 0. X minus 3 is equal to 0. Then x equal to 3. That means the cobalt charge is what here? 3. Cobalt charge is what? 3. Or we can say that cobalt oxidation state is 3. Cobalt oxidation state is what here? 3. So now here primary valency is satisfied by the charge on the central metal atom. Now what is the charge on the central metal atom? It is the 3. But the charge on the central metal atom? 3, right? So now this is the primary valency. Next of all, secondary valency. Secondary valency represent the coordination number of the central metal atom. Secondary valency represent the what? Coordination number of the central metal atom. How can we say the coordination number of the central metal atom? Coordination number of central metal atom, we can identify that. Otherwise, we can say the coordination number. The number of electron pairs donating to the central metal atom from the ligand. Number of electron pairs donating to the central metal atom from their ligands is called coordination number. That means how many electron pairs are donating to the central metal atom, that is equal to its coordination number. Now, if you see this example, what is this ammonia, right? So this ammonia is neutral molecule or neutral ligand. So this is behaving as a ligand here, and ammonia is a monodentate ligand. Ammonia is what here? Monodentate ligand. So monodentate ligand nothing but it can donate one electron. Ammonia is a monodentate ligand. It will donate the one electron pair to the central metal atom. Such type of ammonia is how many present? 6 present. So each ligand donating the one electron pair to the central metal atom. Totally 6 ligands is present. That means it is donating the 6 electron pairs to the central metal atom. Right. So number of donating electron pairs how many here? 6. So that means the central metal atom coordination number is 6. That every say very easy. You remember that every time. Don't confuse here. Number of electron pairs donating to the central metal atom is called coordination number. Number of electron pairs donating to the central metal atom we call as a coordination number, but not number of ligands present in the coordination sphere. Right. So now that example we will discuss now. So this is a primary valency 3 and secondary valency is what 6. And I said that primary valency is satisfied by the negative ion, secondary valence is satisfied by the negative ion, and at the same time neutral molecule. Here it is satisfied by the neutral molecule. And primary valence we are showing the symbol with the dotted line. Secondary valence we show the symbol with the thick line. So how we have to show that, right? So now I will explain you. This is the cobalt. Cobalt is the central metal atom. So I am writing the cobalt here. Next of all, what 6 ammonias are there. Ammonias is the ligand. That means it is a represent the central coordination number. So now here what secondary valence? It is represent the secondary valence. Secondary valence generally we are showing the symbol with a thick line. So how many ammonias are there? 6 ammonias are there. So 6 ammonia we are representing with a thick line. 1 and 2 ammonia. Next of all 3 and next 4 and next one is 5 and next one is 6 ammonias we are representing. This is the what? 6 ammonias we are representing around the central metal atom. Now how many chlorines is present? 3 chlorines are present. But the 3 chlorines are what? It is negative ion. Negative ion and it is present after the sphere. The negative ion which is present after the sphere, generally it is satisfied by the primary valence. Right. So now the primary valence is showing the symbol with what? Dotted line. So how many primary valence is showing ions is present here? 3. That means these 3 chlorines we are showing the symbol with the dotted line. So this is the first chlorine and this is the second chlorine and this is the third chlorine. So totally how many chlorines are there here? 3 chlorines are there. These 3 chlorines are what? It is represent the primary valence. These 3 chlorines are represent the primary valence. So this is the structure for the CONH36Cl3. So this is structure we are getting from the Werner series. Right, this is the one of the example, and we see that the structure is coordinate. This structure is what? Octahedral structure, because coordination number is 6. When the coordination number is 6, generally the geometry of the molecule is octahedral. Right, so the geometry of the molecule is depend on the coordination number. So next example, and here how many ions is right? So I am taking this molecule again, CONH36. CONH36Cl3. When this coordination compound is dissolved in the water, when this coordination compound dissolved in the water, how many types of ions it releases? That means totally 4 types of ions releases, because this is the coordination sphere, isn't it? So this coordination sphere is completely one type of ion, and whatever the species is present outside the coordination sphere, these are one type of ion. That means this is the negative ligand. So how many negative? This is the negative species. How many negative species present? 3. That means when it is dissolved in the water, first of all 3 chloride ions is releases. At the same time, this is the coordination sphere. Coordination sphere completely one ion. Coordination sphere completely one ion. That means CONH36 plus CONH36 plus. So now how many chloride ions is there here? 3 chloride ions. And how many coordination sphere? 1 coordination sphere. So 3 chloride ions is negative charge, that means negative particle. 1 coordination sphere is positive particle. Totally how many ions is possible? 4 ions is possible. These are the 3 ions and this is 1 ion. Totally when this compound is dissolved into the water, totally 4 ions is releases. Right. So this is the one of the topic, and we'll go with the second example. We'll go with the second example. The second example is cobalt and ammonia 5 and 1 chlorine and outside the coordination sphere 2 chlorines. Outside the coordination sphere 2 chlorines is present. Now we have to identify primary valency and secondary valency, right? So primary valency, it is represent the charge on the central metal atom. So what is the charge on the central metal atom? How can you identify, right? So now we'll see that cobalt charge is, we have to find the cobalt charge. So cobalt charge we don't know, we have to take as X. Plus we know that ammonia is a neutral ligand, there is no charge, 0. Plus here one chlorine is there, chlorine is the negative species, the charge is -1, that means 0, -1, right? So next of all what, again here 2 chlorines is present, that means -2 is equal to 0. Totally X minus 3 is equal to 0, then X equal to 3. Again cobalt charge is what, 3. Again central metal atom cobalt charge is what, 3. So now that means primary valency 3. That means primary valency what here, 3, because primary valency, it is represent the charge on the central metal atom. Now charge on the central metal atom which here 3. So that means primary valency 3. Next of all secondary valency. Secondary valency represent the what, coordination number of the central metal atom. Coordination number means what? The number of ligands, number of electron pairs donating to the central metal atom from their ligands is called coordination number. So how can you define the coordination number? Number of electron pairs donating to the central metal atom from their ligands is called coordination number. Now here how many ligands is there? Ammonia 5. That means 5 ligands. And here chlorine also donating 1 electron pair to the central metal atom. Totally how many ligands, how many electron pairs are donating to the central metal atom? From the ammonia 5 electron pairs are donating, and chlorine also donating 1 electron pair. So totally how many electron pairs are donating? 6 electron pairs are donating. That means the secondary valency how much here? 6. So once again very important here. So coordination number of the central metal atom, how can you find? Coordination number of central metal atom is equal to number of electron pairs donating to the central metal atom from their ligands or from their species, from their surrounding species is called coordination number. Now here, about the cobalt, whatever the surrounding species, what is present? Ammonia present, chlorine is present. Here ammonia is the ligand, is donating 1 electron pair because ammonia is a monodentate ligand. At the same time, 1 chlorine is present, this chlorine also donating 1 electron pair to the cobalt. At the time, here what, ammonia, 5 ammonias are present, each ammonia donating 1 electron pair, totally 5 electron pairs. And 1 chlorine donating 1 electron pair, totally 6 electron pairs to donate to the cobalt. That means coordination number of the cobalt how much here? 6. So that means secondary valency 6. Right? So now primary valency is satisfied by the charge on the central metal atom. Secondary valency is satisfied by the coordination number of the central metal atom. So both primary valence and secondary valence we identify here. Now we have to draw the structure of this molecule. Right? So how we have to draw here? So now we'll see that first of all I am writing the central metal atom cobalt here. This is the cobalt. Right? So next ligands. How many ligands are there? 5 ligands is present. Okay. So now here 5 ligands is present, here 1 chlorine is present. So both the species donating the electron pair to the cobalt. Okay. The species which is donating the electron pair to the cobalt, generally it is coming to the in the secondary valency. And the secondary valency we are showing the symbol with a thick line. That means 5 ammonias we are showing the symbol with thick line. So 1 ammonia, next of all what? Second one, and third one, and fourth one, and one more is what? Fifth one. Totally 5 ammonia, and one more is what? 1 chlorine is present. So now this chlorine is present in the coordination sphere. At the same time, this chlorine is donating the electron pair to the central metal atom. At that time, we are showing the symbol with thick line. Okay, and the negative ion, one more important point, the negative ion which is present within the negative ion which is present in the coordination sphere, it is satisfied the both primary valency and secondary valency. Once again, very important point, the negative ion which is present in the negative ion which is present in the coordination sphere, it is satisfied the both the valencies. That means it is satisfied the primary valency and it is satisfied the secondary valency also. So now here the cobalt I am writing here. So now it is a secondary valency, the thick line indicating the secondary valency, and it satisfies the primary valency also. Now you have to draw with what? This is the dotted line. Right? So now how many counter ions is there? 2 counter ions is there. The 2 counter ions you have to show the symbol with what? Dotted line. The 2 counter ions you have to show the symbol with what? Dotted line. So this is one of the counter ion and this is one of the counter ion. Now this is the structure of the what? CO, NH35, Cl and Cl. So this is the what? Coordination complex and the structure of the coordination complex, and when it is dissolved into the water, when it is dissolved in the water, how many ions it releases? 3 ions it releases. How many ions releases? 3 ions. How many releases? 3 ions. Chlorine, how many is there? 2. So coordination sphere completely one type of ion. Outside the coordination sphere, how many atoms is there? That many ions. So 2 chlorine atoms are there. That means 2 chlorions plus one of the coordination sphere. Coordination sphere is one of the ion. So CONH3 5 Cl. This is one of the ion. Totally how many ions is 5 ions. 2 chloride ions, 1 coordination ion. Totally 3 ions is possible. So this is the Werner's theory of this example. So next one more example. Right. So one more example, that is what CONH3 4, CONH3 taken 4, Cl2 and Cl. Cl2 and Cl. Now within the coordination sphere 2 chlorine atoms is present. Outside the coordination sphere 1 chlorine atom is present. We can say that directly the species which is present outside the coordination sphere, okay, it will be ionized and the coordination sphere is completely one ion. That means only 2 ions is possible when it is dissolved in the water. One is Cl minus, one is completely coordination sphere. Coordination sphere is positive charge and that Cl is negative charge. Totally how many ions is releases here? 2 ions releases when it is dissolved into the water. Right? So now we have to identify what is the primary valency and secondary valency. So primary valency is the charge on the central metal atom. What is the charge on the central metal atom? Cobalt charge you have to identify. We don't know that. You have to take as a X plus ammonia is a 0 plus. So that means chlorine, so how many? 2 chlorine. Each chlorine is a negative charge. That means minus 2. And here also one chlorine is present. Totally minus 3. That means X minus 3 is equal to 0 and X equal to 3. Again the cobalt oxidation state is 3. Again the cobalt oxidation state is what here? 3. So cobalt oxidation state is 3. That means primary valence is 3. Primary valence is what here? 3. Now what is the secondary valency? Secondary valency, that means what? What I said the secondary valency? Number of electron pairs donating to the central metal atom. Number of electron pairs donating to the central metal atom is called as a coordination number of the central metal atom. So how many electron pairs are donating to the central metal atom? Ammonia every time donating 1 electron pair. Such type of ammonia is 4. That means 4 electron pairs from the ammonia. And 2 chlorine is donating 2 electron pairs. So totally 4 electron pairs from ammonia, 2 electron pairs from the chlorine. Totally how many electron pairs? 6 electron pairs. That means coordination number is what? 6. Right? So primary valency completed, secondary valency completed. Now you have to draw the structure. So how can you draw the structure? Central metal atom is what? Cobalt. I written the cobalt. Next here what? Within the coordination sphere. This is the what? Neutral line and it represents the what? Secondary valency. Okay. So that means it is a straight line. So totally 4 ammonias I am writing with thick line. 1, 2 and 3. And next one is 1. Totally 4. 4 ammonias I written, right? So next one is what? Remaining chlorines is present. Remaining chlorines. So within the coordination sphere, how many chlorines is present? 2. Within the coordination sphere, if any negative charge piece is present, that is satisfied by the both primary valency and secondary valency. That means these 2 chlorines are satisfied by the primary valency and secondary valency. So now 1 chlorine satisfies the primary valency at the same time secondary valency. And here also 1 chlorine satisfies the secondary valency and now it is the primary valency. So totally 2 chlorines are satisfied by the primary valency and secondary valency. 1 more chlorine is there. Where it is there? That is outside the sphere. Outside the sphere, which ion is there? That is generally satisfied by the primary valency. So now the one of the chlorine I am writing here. So that is with what? Dotted line. That is with what? Dotted line. So this is the what structure of the what? This complex. So now coordination number 6 nothing but what is the geometry of this molecule? Octahedral geometry of this molecule. So this is the what compound and one more thing, it is furnishing how many ions? 2 ions is furnishing when dissolved into the water. One is chloride ion, one more is completely what coordination sphere. So totally 2 ions is furnishes when dissolved into the water. Right. So next last example is one of the very important example here. Right. So CONH3 taken 3. CONH3 taken thrice and Cl3. This is right. So now we have to identify the primary valence and secondary valence. The primary valence how can you identify? Cobalt and ammonia is 0 and here minus 3, then X minus 3. So here minus 3 charge is there. Obviously the counterbalance will be cobalt. Then cobalt will be plus 3. That means primary valence is plus 3. Primary valence is 3. Next of all, secondary valence is what? Secondary valence is nothing but number of electron pairs donating. Okay, 3 electron pair donated from the ammonia, 3 electron pair donated from the chlorine. Totally 6 electron pairs are donating. That means secondary valence is 6. Secondary valence is what? 6. Now you have to draw the structure of this one. So cobalt. Okay, so now it is what? Ammonia. Ammonia is what here? Ligand. So it is donating the one electron pair. That means I am writing the what? Our 3 ions is present, 3 ammonia is present, 3 ammonia is secondary valence is presenting. So I am writing with the straight line only. Next of all, 3 chlorine. 3 chlorine, but chlorine present inside the sphere. The species are the ions which is present inside the sphere. Okay, the negative ion which is present inside the sphere, it will be satisfied by the both primary valence and secondary valence. That means this chlorine is satisfied by the both primary valence and secondary valence. So now this is secondary valence one of the chlorine, and this is the secondary valence one of the chlorine. This is the secondary valence one of the chlorine, right? And this is satisfied by the primary valence also. That means 3 dotted lines. This is. So this is the again coordination number 6, nothing but octahedral structure. Again which structure this is? Octahedral structure. Right. So next what is that? How many ions is furnishing when dissolved in the water? Very important question. How many ions is furnishing when this complex is dissolved into the water? There is no ion is furnishing. No ion is furnishing when dissolved into the water. 0 ion is furnishing. There is no ion is furnishing. Why there is no ion is furnishing? Because after the coordination sphere there is no space. After the coordination sphere, if any space is there, if that will be negative and the coordination sphere will be positive. But after the coordination sphere, there is no ion is present. At that time, this coordination sphere can't be ionized. Coordination sphere, whatever the species is present in the coordination sphere, it will be not ionized. Only the species which is present after the coordination sphere, it will be ionized. Then any species present after the coordination sphere, there is no space. That means it is not ionized. So the number of ions releases when it is dissolved into the water is 0. Number of ions releases when it is dissolved in the water, what? 0. So this is the Werner's theory. This is what? Werner's theory. And for this we can write the 2 types of structures we can write. For this complex we can write the 2 types of structures we can write. So simply we can say